Okay, today we're talking about the sum and difference formulas again. We learned the sum and difference formulas yesterday, and so I want to have you remember this would be the sine sum pattern, because we want to add two angles, the sines of two angles together. And so what is the sine sum pattern? Sine, cosine, cosine, sine. Keep the sign. Very good. Sine, cosine, cosine, sine. Keep the sign. And so what should I write down to expand the sum of angle x and angle y? Sine of x times cosine of y plus cosine of x times sine of y. All right. I just want you to get used to the fact that they could be really any angle measure, x and y, c and d, whatever letters we want. If we're adding two things together, it still goes in that pattern. All right. This is the cosine sum pattern. What is the cosine pattern? Cosine, cosine, sine, sine, change the sign. Very good. Cosine, cosine, sine, sine, change the sign. So that's going to be cosine of angle C times cosine of angle D minus sine of C times, sine of D. All right. Very good. So we're using those same patterns today to help us out. So here we go. Example 1, prove the identity. So this is more establishing identities, verifying identities. These two things are supposedly equal. I could check. I could plug the left-hand side in y1, and I could plug the right-hand side in y2. And if they are supposedly equal, they should have the same graph. They should be identical graphically as well. So, but what we want to do here is actually show how we transform one side into the other side. Bless you. So you have the cosine of 5 pi over 4 minus x. And supposedly that equals negative radical 2 over 2 times the quantity cosine of x plus sine of x. This side fits my cosine sum formula pattern. So we have the sum of two angles. We have the sum of this first angle, 5 pi over 4, and we have the sum of that second angle, x. And, oh, this is the, sorry, it's not the cosine sum formula. It's the cosine difference formula. So how do we expand the cosine difference formula? What is the pattern? Cosine, cosine, sine, sine. Change the sign. Negative turns to positive. And so then we can expand, cosine of the first thing, cosine of 5 pi over 4 times cosine of the second thing plus sine of the first thing times sine of the second thing. Okay. Now, I can think about evaluating cosine of 5 pi over 4. So I'm going to think about my unit circle and 5 pi's over 4. So that would be pi divided into 4 wedges on top and 4 wedges on bottom. And 5 pi over 4 would be 1, 2, 3, 4, 5. What ordered pair is at 5 pi over 4? Negative radical 2 over 2 and negative radical 2 over 2. Good. Okay, that's alphabetical cosine sine values. So what is the cosine value at 5 pi over 4? Negative radical 2 over 2. Can I do anything with the cosine of x? No, I don't know what x is. They didn't give me anything about angle x. So we just get to leave it cosine of x. Plus, what is the sine at 5 pi over 4? Negative radical 2 over 2. And again, sine of x, I have no information about that. So it just stays. Now, what do you notice? Greatest common factor, GCF. Thank you for paying attention to greatest common factor. What do they both have in common? Negative radical 2 over 2. And what's left behind? Cosine of x plus sine of x. And that is exactly what we needed to show. All right. Very cool. And not hard, right? I love the sum and difference patterns. They're so great. Okay. You guys are like, yeah, whatever. Okay. Here we go. Let's turn the page. Example 2, simplify the expression. Confirm graphically. I love all of these questions. I'm going to state it again for the second time. Everything you see today is going to be on your test because it's not something you can just plug into your calculator and approximate, which is kind of nice. You have to kind of know how to do it. Okay, confirm graphically. So again, here we have this expression, and it fits the sine difference pattern. What is the sine difference pattern? Sine, cosine, cosine, sine. Keep the sign. Okay, so we're going to go ahead and expand. That's going to be, let's see, I'll color code again because I really like doing that. The first thing is pi, and the second thing is theta. And so that's going to be the sine of the first thing times the cosine of the second thing minus the cosine of the first thing times the sine of the second thing. This is the point where you have to figure out what things can we actually evaluate and what things can we do nothing with. So what can we actually evaluate? The sine and cosine of pi is an angle measure. Pi is right here on the unit circle. What's the ordered pair at pi? Negative 1, 0. Cosine, sine. So those we can evaluate. What is the sine at pi? 0. 0 times the cosine of some angle, unknown, angle theta. I don't know what it is. And then, what is the cosine of pi? Negative 1. And again, I don't know the sine of theta. What happens here when we go to clean this up? 0 times cosine is 0. And then what do we get on the back end here? Positive sine of theta. Negative times negative turns to positive sine of theta. And supposedly, these two things are the same. So I'm going to go ahead and confirm graphically. What that means is what I started with I'm going to put into y1. And what I'm ending with, I'm going to put into y2. Oh, I need new batteries. Okay. So I'm going to put pi minus some angle in y1 and sine of theta, some angle in y2. And they should look the same. So I'm just going to do a zoom trig. Zoom trig. Oh, that looks just like a sine curve. And yeah, they are identical. So that's pretty nice. Great way to check. All right, questions on that one? That's easy, right? This sounds great. Okay, and last one. Ooh, in 10 minutes, here we go. I really love this question. It's great. Example 3, find all solutions of the equation in the interval 0 to 2 pi. Let's say you don't know how to do the math on this. What options do you have? What can you do to solve this cheater style? Plug it into your calculator. Yeah. Left side in y1, right side in y2, and calculate the intersection. Always an option for any equation. That's always an option. Now, sometimes it's really hard to find where they intersect, and they might never intersect, and you might never know that. So, but I would say a lot of the time that's a great solution. When in doubt, graph it out. Okay, we have cosine of x minus pi over 2 plus sine squared of x equals theta. Big equation, we got to solve for the angle x. What do you want to do? Expand, absolutely. This is our cosine difference pattern. We have the subtracting two angles here. We need to expand that. What is the cosine difference pattern? Cosine, cosine, sine, sine. Change the sign. All right, so once again, I'm going to go to my two trusty rusty colors. I like purple and green today. It's a cool way to go. All right, so I have cosine of the first thing times cosine of the second thing. That's going to be plus because we have to change the sign. Plus, sine of the first thing. Sine of the first thing times sine of the second thing, pi over 2. Don't forget to rewrite the rest of your equation. That happens a lot. You get so carried away with expanding, you forget that there's more to finish writing out here. All right, let's do some cleanup. On this expansion that we did, what can we actually evaluate? Cosine and sine at pi over 2. Right, here's pi. Pi divided into two places is right here. What ordered pair is at pi over 2? 0, 1. Very good. So I can evaluate these things at pi over 2. Let's see. Can't do anything with cosine of x. We're trying to figure out what that angle measure is. But at pi, cosine at pi over 2 is 0. And then we have plus, again, I don't know sine of x, it has to stay. The sine value at pi over 2 is what? At 1. And again, don't forget the rest of your equation. Sine squared x equals 0. What happens when we clean this up? That was like the weirdest sound ever. Okay. Cosine of x sine 0 is 0. So that term disappears, which is really, really nice. And sine of x times 1 is just sine of x. plus sine squared of x equals 0. Now, a couple of options here. Let's just imagine for a moment if we were using a different angle and it turned out that sine of x was multiplied by 0. So that term went away, but we still had this cosine term if this was 1. So pretend for a moment, if you will. And we had an equation where we had cosine of x plus sine squared of x. What could you do? Well, it'd be cosine plus sine squared. Substitute for sine squared, right? So don't forget about anytime you have something squared, there might be a Pythagorean identity that you could substitute in, 1 minus cosine squared. If you needed to change because you had a cosine term. All right, so then you could replace the sine squared so that you get something else with cosine, okay? Didn't have to do that in this particular case. All right, here we have two terms. What should we do? Take out a sign, GCF. Greatest common factor, sine of x. If we take out the sine of x, what's left behind? 1 plus sine of x, very good. And then what do? Set each part equal to 0. Each factor gets set equal to 0. Sine of x gets set equal to 0. 1 plus sine of x gets set equal to 0. And we can figure out now, where does sine have a value of 0? So it has to be at one of these quadrantal angles, right? 1, 0, 0, 1, negative 1, 0, 0, negative 1. So where does sine have a value of 0? 0 and pi. What about 2 pi? It's also 0. Should we put that as an answer? No, it's not included. The parenthesis. We don't want to include the answer is 2 pi, but 0 can be included. So x equals 0 and x equals pi for solutions here. Over here, I'm going to move the 1 over. So we get sine of x equals negative 1. So where does sine have a value of negative 1? Yeah, right here at 3 pi over 2. So we get x equals 3 pi over 2. All right, do you have any questions for me? Always a good idea to check answers, so I'm going to take a minute and plug this in just to make sure that all 3 of these answers work. But you guys can get started on your homework. CP 38.